Good afternoon, everybody. My name is Andrew Jordan. I'm the product manager on the IoT team for Super SIM. And today I'm really excited to talk to you about the work we've been doing to build this next generation platform for IoT connectivity. We can give you a quick overview of where we're going to go today. We're going to talk about kind of like the broader framework for IoT connectivity. How does pricing work? What is coverage? How do those go together? We're going to talk about some of the trade-offs. So when you're selecting a vendor, if you select one type, what is that like? If you select another, what are the pluses and minuses there? We're going to talk about the Super SIM, how we built it, what all the components are, and how we put them together. We're going to talk about roadmap. Where is Super SIM now, and where are we going? Then to wrap up, I'll be joined on stage by a customer who's going to talk through their platform and how they're participating in the Super SIM beta. So let's start off with the big question in IoT connectivity. It's all about cost. Dollars, euros, RMB, however you're paying, you need to make your business equation work where you're getting the best coverage for the least amount of money. And that's kind of an interesting trade-off in IoT and in wireless connectivity generally. So the dynamics of the wireless market make cost and coverage inversely related. And the reason that happens is that there's two fundamental types of companies you can buy connectivity from. The first, mobile network operators. We're all really familiar with these. These are the people you probably buy your SIM card from that's in your consumer phone. It's the AT&T and Verizons and the Vodafones of the world. And they have a fundamental cost advantage when they're delivering IoT connectivity. They own the spectrum, they own the network. There's no markups, and if they're sufficiently motivated, they can dig all the way down to cost to offer you this service. Then you have a second class of providers in the IoT connectivity space. You have resellers. Now, they don't own their own networks, but they're able to get roaming deals and piece them together so they can get pretty decently priced coverage everywhere. And they generally have the advantage of wrapping that connectivity in some way that makes it nicer for you, an IoT developer. Maybe it's a nicer business model, better logistics, or an API that's not SOAP. So let's talk about some of the characteristics of a reseller. With a reseller, you generally have quite simple SIM logistics, only one SIM. You'll probably have a relatively low integration complexity. A lot of the resellers are more modern companies. Maybe you'll get a really nice REST API. You'll get pretty good coverage. Generally, they have put together deals, so you get A to Z coverage all over the world. But the pricing, you're really only going to get roaming rates from a reseller. So you'll never get that kind of MNO direct on-net pricing. The next type of vendor you can buy from is an MNO directly. Your SIM logistics here, probably pretty simple. You're only going to get one SIM card. Whether you're able to get a low volume of those SIM cards or how quickly can be really challenging. Integrations tend to be more complex. The APIs here tend to be a little harder to use. Maybe you actually have to integrate against kind of like 3GPP standards. It can be challenging. I think the big thing that is hard to wrap your head around for buying from an MNO is while they may have a wide number of operators available through their roaming deals, in their home market, you're generally only going to be able to get onto their network. So coverage in the home market is actually probably going to be the worst. However, if you're on that home network, your price is going to be rock bottom. So if you kind of want to extend this a little further, there's another strategy you can take on, which is to use multiple MNOs. And we think this is really common, especially in automotive, where a vehicle could use hundreds of megabytes, maybe a gig or two of data in a month. So the cost per gig that you're paying for your connectivity is paramount. So here, maybe you're willing to take on a slightly more complex strategy. So you're going to go out and partner with multiple MNOs. This is going to make your SIM logistics way more complicated. You're going to end up with multiple SIMs. So you now need to track from your inventory of SIMs, the devices that those SIMs go into, and then the countries that those paired devices and SIMs end up in. You need to make sure that your South America SIMs end up and your South America cars end up in South America. And if that car ends up in Germany, it's probably not going to work, or you're going to pay a really high roaming rate. Integration costs are going to be much, much higher. You're going to need to integrate against multiple platforms and also maintain those integrations. Billing tends to vary between partners as well, so you'll need to reconcile your usage versus your billing across multiple different partners and multiple different integrations. By putting together this many providers, you are going to be able to get good coverage, and especially in those home markets, you're going to be able to get really low data rates. So for customers where low data rates are the most important thing, they're willing to take on these complexities. And we see some customers who have teams of 25, 30 people just to manage this complexity, but overall, it works in their economic model. So as we looked at kind of these two approaches, going direct to an MNO, getting really low pricing with not as great coverage, or going to a reseller and getting really good coverage, but paying a slightly higher price, we wanted an approach that gave us the best of both worlds, something we could give our customers and kind of split these up. So we were thinking about how to do this, and we realized that this is actually a really common pattern within Twilio. This is something we've done a number of times before. And specifically, we've done it for voice and for messaging already, which is to take the connectivity piece and decouple it from the software piece. When you send an SMS on Twilio, there's only one API, but behind it, there's hundreds and hundreds of carriers and thousands of routes we could send this SMS over. And the value we provide you as a customer is abstracting all that away. So we were trying to think about how can we do this for mobile? How can we do this for IoT connectivity? And we realized in order to do that, we would need to run the software ourselves. We would need a mobile core. So how many of you are familiar with a mobile core and what it does? You all love esoteric telco. This is great. So a mobile core is the kind of fundamental software element, or in a lot of cases, hardware element of a mobile network. What it does is it authenticates the SIMs, kind of verifies that they should be able to connect to the network, and then as those SIMs set up a data session and start sending data from the modem to the mobile core is then what breaks that data out to the public internet. So make sure that your packets get from your temperature monitoring sensor to the mobile core and then out to Amazon IoT or whatever backend you're using. It also handles SMS routing, all the billing, usage aggregation, et cetera. So we realized we would need this, and in true Twilio fashion, we'd need to run it at scale, distributed in Amazon. So that brought us to this idea of the Super SIM. And the Super SIM would be one SIM with one integration, with global coverage, but we wanted to bring these MNO rates. So in order to do all this, we need a bunch of infrastructure, a bunch of different components to bring this all together. So we started off by building a mobile core. We went out, we found a team who was building a software core out of a research institute in Germany. We acquired that company, Core Network Dynamics, and that became our mobile core team. And owning our own mobile core that's pure software running in Amazon gives us a few fundamental structural advantages. The first thing, we're not paying licensing to anyone. So when we're offering you, the customer, a cost structure, there's no markup in the middle. Most importantly, and as a PM, my favorite feature is we own the roadmap. So as opposed to being beholden to a vendor where we say we want something and they say that's fantastic, our next release is in 6 months, we can go talk to our engineering team and get it on the next sprint. Something that's underrated until you've really run a quite large IoT fleet is visibility. When you're trying to debug a distributed system, when you have devices in Argentina or China and you need to understand which ones are working, which ones aren't, and why, being able to see edge to edge is incredibly valuable. And by pulling this infrastructure up into Amazon and making it our own, we can now see all the signaling and all the data traffic flowing from all our SIMs and expose that to you, our customers. And lastly, we can distribute this globally. Because MNOs are traditionally quite regionalized, they generally only have a mobile core in one location, which is great as long as you're also running your devices really close to that location. However, as you start distributing globally and the distance between your device, your core, and your internet breakout start to stretch out, your data latency starts to increase. So if you're going to do a truly global deployment, what you want are globally deployed cores as well. With deploying software into Amazon, we can do this really easily in the same way that we already do global low latency for our voice and video products. So if you have a great core, it doesn't matter if you don't have a good network to connect it into. So over the last 2 years, we've done a ton of business development and partnered with T-Mobile, Hutchinson, Telefonica, Singtel. Each of these aren't just a single carrier, but groups of carriers. So we get access to all of the networks that each of these groups operate, in addition to all of their roaming deals. And this gives us tier 1 rates on many continents and an A to Z roaming deck for the entire world. Lastly, if you're going to build a super SIM, you're going to need a super SIM. So we went out and designed our own SIM card, built in conjunction with Thales, that has multiple providers on a single SIM. This allows us, in combination with our core, to pick the right provider, have it lit up on the SIM for wherever your device is deployed. We also stood up an over-the-air upgrade platform, because we understand that even though it's hardware, we want it to behave like software and receive updates in real time. We want our customers to be able to confidently deploy a super SIM today. As we add new operators, new features, have it continue to get better along with the platform. So if we bring all these three things together, they make the super SIM, which is not just a SIM card, but the entire product. And I think it gives us really fundamental advantages in both cost and coverage. And I'll give you an example. Let's take, for instance, Mexico. Say you want to deploy 100,000 bikes into Mexico, you're a bike sharing company, and you want to think about what are your options for buying connectivity? Like, what vendors can you go to and what can they offer you? Let's look at kind of 3 different options. So the first is an MNO strategy, right? You want to go directly to Telcel. They own a bunch of networks in Latin America. And from them, Telcel will sell you access to, of course, Telcel, but also only Telcel. They'll, however, give you a really good rate for it. A reseller like Hologram doesn't have a local relationship in Mexico, but they have a pretty big roaming deck. So they'll give you access to 3 different networks within Mexico. And that's really good, but because their roaming rates, they're quite a bit higher than what you're going to get from Telcel. With Super SIM, it's a bit of a hybrid approach. So you'll have a choice. If you really want the lowest possible rate, we'll offer you Movistar, which is a Telefonica company, at a local rate. But we can also offer you, on the same SIM, roaming rates onto AT&T and Telcel. So you as an operator can make a choice. Maybe it's like a higher usage device, something that chews up a lot of data, and it has a big antenna and a lot of battery life. So you really want to only open up Movistar so you can get the lowest possible price. We can do that. Or if maybe it's a device that's moving a lot, has a lot of mobility, and you want to keep track of it. Something like the dockless bike share we mentioned earlier would be a good example. There, coverage is probably more important to you, so you want to open up all those networks. So with Super SIM, you can choose between more coverage or lower price programmatically through the console. So before you reach for the Super SIM, we think there's a couple other advantages to Super SIM that we're really excited about. One is route depth and redundancy. From building our voice and SMS product, we understand that failures happen, and the ability to route around a failure is incredibly important to maintaining customer uptime. Because we have multiple providers on the SIM, if one of those providers were to go down, we have the ability to bring up a backup provider, giving you more depth. Also, redundancy. By using all those providers, we generally have 2 or 3 different routes to most operators in the world, giving us a lot of flexibility in terms of how we route traffic. I alluded to this earlier. We're going to provide user-defined routing on Super SIM. This is incredibly important in IoT, and people who have deployed a lot of devices know that this can be sometimes quite painful. Generally, IoT devices, you ship them, they have a limited number of radio bands on the device. And that's because as you add more radio bands, your whole bill of materials goes up, so you have an incentive to keep the band support narrow. However, that can be a problem if within a single country, different operators support different bands. So your device may actually only be compatible with one operator in a given country. If that's true, it is incredibly important that you can choose which operator your device can connect to, and your connectivity provider does not do that instead. We see some providers where they provide one country price, and they move around which operator they're going to use in that country in order to optimize their own commercials. and it can sometimes be quite problematic for IoT developers. So we think offering user-defined routing, where you go into our API and console and pick where you want to connect, is a huge value specifically for IoT. Something else we think is really important is real-time usage and eventing. Because we have this end-to-end visibility, we can tell you as your devices use data at the time they use data, not after a couple hours after CDRs are processed, not after a long billing pipeline, but in real time. And one of the values we want to push with Super SIM is to give you streams and real-time alerting for when your devices connect and as they use data. And the last thing, because we have this, our own core, you can plug into it. So if you're a really big IoT consumer, you already have really excellent commercials with an MNO, but you want to consolidate those commercials and maybe coverage in other countries on a single platform, come talk to us about plugging your existing deal into our infrastructure. So where are we going with Super SIM? Right now, we're running a pilot with a handful of customers to get feedback. We're going to go into an open beta in Q4 and start shipping tens of thousands of Super SIMs. We have a pretty long pipeline of customers who have signed up, and we're continuing to accept new signups. And we'll be going to GA in Q1 of next year. To talk a little more about one of the applications for Super SIM and one of their products, I'd like to welcome up Steve Cheney, co-founder of Estimote.
Good afternoon. Thanks for coming to the session and having us here. So I'm going to explain a little bit about what my company, Estimote, does in the context of programmable IoT, and I'm going to try to share some fun stories about what our customers generally have done. IoT has developed quite a bit in the last few years, so we're really excited about what Twilio is bringing to the table to add network connectivity globally with the hardware that we ship and that you can just sort of bring onto a network with very low friction. So what does Estimote do? We think of ourselves as a platform that enables sort of true end-to-end connectivity for tracking, maybe assets or people. And we do that in a way to expose data and new use cases, frankly, that the internet is evolving to really take advantage of. So if you were to think about, for example, a Tesla self-driving car, I'll give you an analogy. When the Tesla car has to navigate and turn right or left, it needs to do so in a fraction of a second in order to make sure it doesn't hit a tree, right? So there's a real-time compute engine in the Tesla vehicle that decides whether to turn left or right. That's a really high performance, really low latency, very extremely important component for a self-driving vehicle. Of course, they also connect to the internet. But if you look at the high performance quadrant of a sort of 2x2, and then you kind of go to the other side and you think of very low cost applications for adding the internet that maybe are performance sensitive but don't need the performance of like a Tesla self-driving vehicle, that's generally the direction that we plan, and that's where we're adding intelligence to kind of the edge of the network. And when we do horizontal platform, really curious things happen. This is a tweet from a couple days ago that I just added at the last second because I was searching on Twitter. And it turns out, NASA is using this and sending our beacons to Mars or something like that. Somebody took some pictures in the NASA space station. So what are customers like this doing with our platform, and how are they enabling new use cases that didn't exist before programmable IoT? Well, they're doing it in a variety of ways. You could think about that if you have an asset, such as like a cart inside of a vehicle, that cart may contain packages, and it may go from one distribution center to another fulfillment center, and it may be unloaded. Now, the cart costs something, the cart needs to be tracked. And 10 years ago, it was extremely expensive to figure out what you were going to do with that. RFID notwithstanding, which is a really dumb technology. So now we have customers that are enabling the tracking of assets by attaching a smart hardware device to it, And now in sort of 2018, 2019, the phenomenon that's occurring today that's very real is that people are actually now connecting an even smarter device that has a modem chip in it that can just instantiate on any network worldwide. Those modem chips, I'll give you a demo and talk more about them. Quectel makes one, we use theirs, we use a variety of them, but they're sub $10. So you can think about adding the internet to an application for a few dollars. In the scooter business, there's like a large problem with understanding what's going on with these devices. People are throwing them in lakes and they're getting lost. We're working with companies in the scooter space to integrate at the firmware level some of this like Bluetooth functionality whereby it can broadcast where it's at. And that becomes really interesting if you're gonna, for example, collect the scooters. Maybe in this case you have somebody that collects them and doesn't use a barcode to scan them in, but they just automatically, when you place them in the truck, it knows that they're in the truck. And what's happening is, in that case, the scooter, again, is reading and ingesting a Bluetooth signal, UUID, that would be attached to the vehicle, right? And then it's talking to an estimate service in the cloud that's registered with that beacon, and it understands physically where it is in the real world. We're seeing a lot of interesting things happening around how people are navigating. And we're not in the business of sending proximity marketing. It wasn't sort of Estimo's core belief that when you were walking down the laundry detergent aisle that you would get a coupon for 10% off Tide. I frankly was never motivated by that. We thought that was a really trivial, sort of useless use case. And the advertising space could also benefit from microlocation for making ads better, but it's not something that we're focused on. This example is really more, how could you actually, to take a negative stigma away with tracking, how could you actually be able to locate, in this case maybe human beings or your dog, and ensure that they were on the journey that they thought they were going to be on? Did the child enter the bus? So that's the kind of stuff that's really, really provocative and really fascinating. Again, as a platform that's horizontal, we often don't know what our customers are building. They'll come up with really incredibly exciting ideas, these Cinderella stories where they'll come up with a use case and it's adding value to the world. This is one of them. I'm going to demo you this platform. In the hospitality industry, there's a problem, believe it or not, with housekeeper safety. So because there's so many hotels, so many rooms, so many housekeepers, often when they're on property, they feel that they're either threatened or maybe there's not a lot of people on property because it's in the middle of the night. We've worked with most of actually the world's largest hotel chains now in full production to enable housekeeping staff with a small device that I have in my pocket here, and it will get even slightly smaller, so it's about the sort of size of an Apple Watch. This device has a single-purpose button on it, and if a housekeeper pushes the button, then inside of the property, we have a variety of sensors that sort of plug that person into that specific room and send an alert in the cloud. And of course, alert law enforcement or tell the property owner that they need to check up on that person. So those are some really amazing things that are happening. And a lot of this is really easy to program with Estimo. About a year ago, we came up with an idea that IoT is complex, and it's very complex not just in hardware, but this stuff called firmware that's compiled onto the chips that you have to understand a language for. That's not really the common framework and language that most of you probably think about when you think about programming for web. You think about JavaScript. So we thought, well, why wouldn't we be able to take JavaScript and actually just compile that right directly into like a device and sort of give a higher level language to a developer? We thought it was like a really provocative, interesting idea if we could do that. And so I'm going to show you that product. The product has a variety of sensors on it that are collecting and pulling in data. It has GPS, so it can be, again, a hybrid indoor-outdoor system. It has connectivity via Twilio Super SIM to a variety of networks worldwide. It will, the device we use will work on both LTE-M and IoT narrowband. Extremely low power. You can use it for a very long time. And for example, this panic button, it can actually last for 6 months or a year without charging it, depending on the frequency of the use. So this is like really, really low cost, highly integrated SoCs. We have a demo that I'm going to give you using a new chip that we actually just launched today. a new device called, using a radio called Ultrawideband, which enables inch precision. It's one of the most amazing things we've ever seen. Bluetooth is an inherent part. People associate beacons with Bluetooth, but Bluetooth is just really kind of like a sort of one part of the sensors. It does allow you to talk to a phone seamlessly through Bluetooth Low Energy, but it's not really the core of what we're doing now. By working with Twilio, we're going to enable on a variety. This is a developer kit, so that's why it's pink. It's part of our branding. We typically make hardware that customers would use in enterprise, and it's more of a standard form factor and kind of like a standard color, but we like to be flashy sometimes with our developer kits. The Twilio relationship allows us to ship these. Like if you go to estimote.com and buy one, they're going to just ship around the world and they're going to work. So it's really powerful. Today, part of our product launch, we just put out what we call an AI beacon. And the reason we're calling it this is that in the upper left, you see that it actually has the ability to auto-learn what's happening around movement. And this is an inertial sensor. So it's called an IMU, inertial measurement unit, that we've integrated from STMicro. We have on the device. It's a 6-axis accelerometer and gyroscope. But more importantly, it also will actually keep the main processor on an extremely low power standby state, and it will only wake it up if it's like detected known patterns. So as an example, we have an insurance company in the auto insurance industry using this in vehicles, and when the vehicle is moving, then you can detect that motion. But if it actually has more of a severe movement indicating a crash, then it will register more G's of force on the beacon. And we have that insurance company now using this product inside of a car to detect a crash to do two things. One is to, if it's a severe one, send somebody, a first responder. And additionally, if it's a small crash, maybe they don't want to actually have like a insurance agent go out in the field and figure out how to pay this person. They just like auto-generate the claim. This is something we would have never thought of. It's just incredible. So this device, again, that is available today, that's new, has that new inertial sensor core, and then it has the really, really precise distance using ultra-wideband. Ultra-wideband is a radio. It's a different one than Bluetooth, and I wouldn't focus on UWB or ultra-wideband as the acronym. It would be a little bit like saying, hey, it's a Bluetooth, but you can if you want. We do. It's a new tech that's really becoming kind of mainstream because the chips that are inside that are powering this, they use time of flight and arrival of detection for the really extremely fast radio waves that are bouncing around. And the processor is able to sort of mimic and detect where it's arriving from to give a precise location. It's literally 100 times, maybe 1,000 times higher fidelity than Bluetooth. And it's starting to become a thing, and we're really excited about it. Similar to LiDAR, in that LiDAR for self-driving vehicles measures how far the laser light has gone. So let me show you a demo. We have different customized form factors, and we can talk to you more about that. We'll also have a booth in the IoT section. It's an example of a PCB. OK, so what I'm going to show you here on this console is the Estimote Cloud dashboard. This is our IDE that has a variety of different apps and ownership of your account for enterprise for beacons. You might be a department store and have 10,000 here. This is a way to programmatically figure out what's going on. Let's open up one of these apps. In this case, basically a demo that does enables a panic button. So when we're speaking about housekeeping safety, I'm going to show you something that kind of looks like that. And as you can see here, there's something really interesting going on, which this is like actually written in JavaScript. So this micro app code, I'm actually going to compile to a beacon. So the beacon in my pocket, I'm going to pair with right now. And this is another interesting thing that a lot of people don't know. You can use Chrome to pair through Bluetooth. So I'm actually speaking to this through my computer. Now, you could actually, through a heartbeat of a Twilio call to a network, program something on the other side of the world. But in this case, I'm actually talking here. So let's change something in the code. For example, I was using Andrew before. Let's change it to my name, Steve, with the panic button. And you can sort of see there's a variety of ways that this is scanning for identifiers. It's looking for it has like defined as I/O presses. The button is programmable, so you can just change how you want the button press to occur. I'm going to go and compile this and send it to the cloud. For the sake of the demo, does somebody want to give me their phone number? 519? 569? 9501? Okay, so check that's right. What I just changed there is in the cloud console. The initial top pane of code, I actually compiled that and I sent it to the beacon, right? And I'm actually going to disconnect because I just compiled. I think I compiled it, but I'll do it again. I'm going to actually disconnect from that beacon now and see it successfully started the app. The code that the gentleman just gave me his phone number for is actually using Twilio. It's using my Twilio credentials. That's running in AWS. That is going to take, sorry, it's hard for me to see here. What I typed in the cloud, and I just deployed that. So that code deployed in the cloud, okay? Now that just occurred on this device right here. So what I'm going to do is I'm going to do a long push to turn it on, and I'll just verify it's turning on. Again, as a housekeeper would move through a property, you could imagine the indoor infrastructure, the rooms talking to this, and as they're moving around, it detecting where they are at, right? So you got an alert, and I was trying to turn it on, and you can see that the alert fired here on the lower right-hand part of the console, which is good. It turned the modem on at 212. I think I hit it again a few seconds later. It said zone null. I'm supposed to be scanning for the identifier. They would have been in one of the rooms. I think I did the demo on the code fairly quickly. But what happened there was this identifier was associated with me, and that was programmatically able to talk to the network and boot up. And we could actually ship those to a number of customers worldwide, and they would be able to install those and just give those to staff. So you could actually think about the industries that are changing with this tech, right? One more demo and then we'll be done. These are the new ultra-wideband beacons. I'm going to turn these on, and I'm going to show you what's happening. These are going to be communicating through the radio, and they're going to be attempting to approximate the location. So you can see here there's one that's blue, and I'm going to sort of like give that to Andrew. And as I move along here, what happens to this beacon? So it's ranging the distance. This is just absolutely mind-bending technology. This is called ultra-wideband. This is shipping today. We're able to do this micro-location for people that want extremely high fidelity for asset tracking. So you could think about a dog moving around, a robot. You could think about wanting to understand someone on the hard hat in a construction industry, where they're at inside of a fulfillment center. So this is like extremely low power. We can actually, depending on the configuration, do this and have it last for multiple years. If you'd like to talk more about any of this stuff, thanks for attending the session. We'll be downstairs today and tomorrow. Really appreciate your time.
Thank you so much. Before we close, I just wanted to plug, our team is going to be talking about a couple other things throughout today, specifically related to Super SIM. If you want to learn more about the Twilio mobile core, what components are in it, how it works, my colleague Jonas, who has been grinding with the team in Berlin to make that work, has a talk at 5:35. My colleague Kadar will be talking about narrowband. And as Evan mentioned before, we have 3 workshops today. If you want to get your hands dirty and play with an IoT device, we have one at 2:20, and then tomorrow at 2:20 and 4:15, chance to get your hands on some hardware and some SIMs and build your first IoT device. Anyways, thank you very much, everybody. My name is Andrew Jordan. If you want to talk about Super SIM afterwards, I'll be just outside. Thank you.